Okay, so good afternoon, everyone. We are starting the last session of today and the last session in this building. I'm Jan Hajič from Charles University in Prague, and I will share the session, not only the talks, but also chairing the session with François Yvon. But let me first introduce François, who will be talking first. François Yvon is the former director of LIMSI in France, which has now been merged and to form a much bigger institute in Paris, which we have seen in one of the presentations this morning. François is a senior researcher in language processing, especially in machine translation. We have shared many projects with François, both on machine translation, language technology, and also some projects where we are stressing the issue of language equality and technology for language equality in Europe. So in order to be short, I think I will stop here and ask François for his talk today.
Thanks, Jan, for the introduction, and also thanks to the organizer for having me here today. So what I will try to do in this short 20 minutes, I will try to discuss issues related to the development and also use of these large language models that we now have at our disposal, that we train. And I will do this in the context of a project that was already mentioned this morning, the Big Science Project, which I am a member of and on which I'm currently working. So the question I will raise and I will try to discuss is about the multilinguality of today's tool, and especially multilinguality of these multilingual language models. So it's interesting first to start with old stuff regarding the universality of language. I mean, we know that we share with all our humans on Earth the same brain, more or less, and the same organs to produce speech. But on this observation has given rise to a long tradition to identify universals in language, mostly in the traditional linguistics tradition. In terms of concrete realization, these attempts have so far failed to identify practical outcomes of this idea of universals. And if we look at one reason why this should be the case, is that the linguistic diversity on Earth is comparatively to this unique brain or unique vocal tract is extreme. We have about 7,000 languages on Earth, and this statement somewhat hides the fact that a language, even English or even Czech or even French, are not monolithic stuff. I mean, there are idioms and variants and so many forms of one language that what we observe, if we look at linguistic diversity on Earth, is that it is enormous. Many of these languages are hardly documented, and most of them are unwritten. Furthermore, we don't have not only a large number of languages, but we have a huge diversity of them. Anyway, we look at these languages, if we look at the script, if we look at the phonological system, if we look at the morphology, if we look at the syntax, we will see a great diversity of process and of ways in which meaning is exchanged through language. And as NLP these days has turned into something that is really data-based, it seems like an impossible goal to achieve that have one model, one statistical model, recover this kind of diversity. So it's no wonder that most approaches over the past like 30 years have abandoned any idea of universality. Maybe speech is an exception there, because there has been early attempts to develop like a universal model of speech for some years. But apart from speech, I mean, there has been very few attempts to develop unified models for language due to this extreme variability. Yet, if you look at what is happening these days, you will see that more and more language models, more and more artifacts claim some kind of multilingualism. So if you look on this website, where you can find a large number of linguistic tools on models, you will find that many of them are claimed to be multilingual. So the question I will try to address today is in which sense are they multilingual, and how can we evaluate how multilingual these multilingual models are? And as a start, I will try to revisit the concept of monolingual model, monolingual pre-trained language models that have been so successful in the past few years. So monolingual models are based on the idea of trying to represent words, let's say words, into vector spaces, so that the distance in these vector spaces would capture some notion of the meaning of words, with the intuition that related words, for instance, synonyms, should be close in this embedding space. And as an example, I don't know if you can read on my slides, it's maybe too small, but I mean, this is a set of words that are nouns referring to football teams. And I'm sure the Sparta Prague is not so far in that space from the main dots that you can see on my screen. So how is this done? A very effective recipe has been proposed to train systems, or to train models, that is to train the parameter of these models using tasks for which we have cheap or even free annotations. Some of these tasks are illustrated on your screen. One of them is simply to predict the next word in a sentence. So I will use in the next slide this idea that what is in green or gray is what we give the system, and what is in blue is what the system has to predict. So basically, we train the system so that it will complete, in the first example, it will complete a sentence. And if it fails, we will update its parameter and do this over and over again on gigantic corpora of text. And as you can see, this just requires text. You don't need to have any annotation. You just mask a word and ask the system to predict it. There are several ways to achieve this goal. I have illustrated 3 on my screen, but there are, of course, several others. So one of them is to guess the next word in a sentence. One of them is to guess a missing word in a sentence. And one of them would be to reconstruct a noisy input, as is illustrated on the third example, where you can see in the input part, in the gray part, you have a noisy version that the system is trained to reconstruct and to fix the missing words and the errors. So this approach has been extremely successful and can be trained at scale with corpora containing billions, typically billions of words. So once you've trained the system, what do? Basically, what you do is you replace whatever preprocessing scheme you had with these pre-trained embeddings, and you observe improvement. So this is illustrated on this small graph that you will see later again, where the input to the system is an email. We will go through this embedding phase with our pre-trained embedding, and then on top of it, train a text classifier to decide whether it's a ham or whether it's a spam. Okay, so this is one example of task. We can do this for many, many tasks. And it has been observed through many experiments that if you do so, you will increase the performance of your system. Sometimes you will increase them a lot, and sometimes you will increase them extraordinarily. Sorry. So it works across the board for all NLP tasks. And in fact, 5 years after this was discovered, everyone is using it in all situations. So if you don't use it, you fail. So this is one way to use these pre-trained systems. Another way to use them, which is somehow more innovative, is to use the fact that they can generate text. So for instance, you can ask the system to generate more text. So if the input to the system is this sentence that some of you may recognize, the system will be asked and maybe will generate the continuation of the text. And in fact, if you use this property of text generation, you can use the system to answer questions. You just ask it, answer this, then you ask your question, and you expect that the system will generate the right answer. Or you can also ask the system about the polarity of a statement. Just input a statement, ask the system about its polarity, and expect the system to answer the question. So many tasks, in fact, can be framed into generation tasks, and the realization of this has meant a lot, because once you have a pre-trained system, you can turn it into a multi-purpose NLP processing tool, NLP tool. So to recap this introduction on large monolingual systems, they can be trained effectively without supervision. So this means that the training is almost free. And they are extremely successful in terms of performance. And last but not least, corpus and model size matter. So you have to use a very large corpora to get the performance you would expect from these models. So now about multilingual models. Why do we need multilingual models? One reason is that we would like to have these systems, these pre-trained systems for all languages. But when we look at the diversity of language learners, as I said, most of them are unwritten, which means that most of them have no resource, or hardly no resource. So this is a map from a paper by Joshi and his colleague 2 years ago, where he plot in a two-dimensional space the level of resource or support for all the world's language. And at first glance, you say, where are the languages? I mean, I can't see so many dots on this screen. The reason why all the languages are here, meaning they have no resource at all, no annotated resources at all. Okay, so if you look at the 5 or 6 groups that are defined on this slide, you will see that the largest group is the group in green with hardly no resource. So for these languages, it's really difficult to see how you could invent training data to have the kind of technological support that you can get from these large language models. And these languages altogether, so there are about more than 2,000, they still represent 1.2 billion of human speakers on Earth. No language support at all. So one solution for this that has been proposed is to develop multilingual language models. So how does that work? The intuition is exactly the same as for monolingual models, except that you expect that the embedding space you build will work cross-linguistically, meaning that not only similar words would be closed in this space, but also mutual translation of words will also be closed in these words. So this is what you expect. Then, if you remember my first slide, the diversity of scripts, you can ask yourself, how can I reach this goal? One way that was extremely effective to reach this goal is to forget about the notion of a word and process everything as pure byte strings or subword strings. So here you have what the first article of the Declaration of the Human Rights would look like once chopped into small substrings across that can be found in all languages. And you can see that there are some kind of lexical overlap that is accidental in that case between the French, the Czech, and the Italian version. You have some words or some subwords that occur in all these languages. Once you've done that, basically you're in business. You can do exactly as before. You can train with the same objective, so predict the next word, recover a word that has been masked, or denoise a noisy objective. And this is all. And doing this, you're able to train multilingual language models. And we know that if we, on top of this, add parallel data or bilingual dictionary, we can get slightly better. So how can you use this? As I will show you, you can use this as before, either to perform some kind of linguistic tasks and also to do multilingual text generation, as illustrated on this screen, where you can see an example of translation that is done as a generation task. You just prepare the system with this prompt, translate into English, and then so this is bad. This will be translated to French. Translated to English is easy. And then you give it the English sentence, and it should produce a translation in French. So it's really simple to train this system. And in fact, the claim is it helps improve the technological support for these low-resource languages that need it. And my next question is, how do we measure success in that case? And this is a difficult question. We had long discussions about bias, for instance. So what is the target of this multilingual system? Should we expect them to treat every language in the same way, with the same level of performance, or can we accept that some languages have better performance than others, or maybe some are more difficult than others? It's a difficult question that I will not answer today, but I mean, it's an important question to discuss how we will measure the success. So one criterion for success is monolingual performance. So it's true that you can take a multilingual system and, as previously, train it to predict English spam, and it works. But the same system can also be trained to detect French spam in French, and it works. So this has been shown for many languages. So instead of having two separate models, now you have one big model that can be adapted to monolingual tasks for many languages. That's one way to evaluate it. Another evaluation that has been performed is to check the idea that words that are similar would have a close or nearby representation in the semantic space. And this has been done through the word alignment task, where with co-authors at Munich, we propose a technique to align words based on their similarity in this embedding space, and that works for many languages. More interesting is the third use case, where instead of training a spam detector in English to apply it in English, or training it in French to apply it in French, in that example, you can train it in English and apply it in French without any French example. This is great because, I mean, for many languages, we only have training resources in English. So, in fact, we can turn these systems as a kind of a multilingual transfer tool. Then you can also try to use this system, as I said, as a text translation tools. And it's interesting to see that even though the first attempts were really poor in terms of scores, so I'm showing here translation quality scores, the higher the better. You can see that the last version of a large multilingual system, Palm, is very close to the best monolingual translation model. So the gap is slowly closing, and we see a more and more effective translation system built with these principles, which is an amazement. Now, there are some caveats that I would like to discuss to conclude my talk. The first caveat is that when you look at these multilingual systems, when you look at the data that has been put in there, some will say it's biased. I would say it's skewed. The result is the same. They are mostly English. So you can see here the top 15 languages, and I stop at 15 because this is Czech. I must apologize. There are 100 languages in this system. So the 15th one counts for 1% of the data, which means that the rest of the languages are really very small portion. Likewise, in Bloom, the big science model, it claims 59 languages. In fact, it has 46 natural languages. And again, the distribution is also very skewed, even though English has only 30%. And you can see a couple of non-European languages have a substantial share, like Chinese and also Arabic. So these models are mostly English. They are proprietary, and they are difficult to run because they are huge. Okay? So one of the goals of the Bloom project was to try to understand better these models, why they work, and also how we should measure their performance. So I give here very briefly some of the results that has been found in previous study. We know that they work without lexical overlap. So even though you take two languages that have no word in common, still cross-lingual transfer may happen. And to the contrary, if word order is really important. So there is some kind of universality of word order at play here that helps to train these multilingual models. And if you change the word order, like you transform randomly sentences, you will break cross-lingual transfer. It has also been found that lexical alignment helps, and also typological similarity helps to transfer. So this is what we know, and this is very little. What we don't know is much larger. We don't know the impact of language distribution because everything has been done with English as a center language. Sorry, I must conclude. We don't know the impact of the model size exactly. So we know that the larger models are working better, but we don't know how large they should be to see this kind of multilingual effects. And we don't know exactly which linguistic property help or break transfer. So this needs to be investigated. And there are many, many other things we don't know, especially related to text generation. These models claim to be able to some kind of multilingual text generation abilities, but in fact, we don't know if they can generate realistic multilingual output. We don't know if they can generate text with multilingual prompts, because all the prompts that have been tried are in English. And we don't know if they can answer questions cross-linguistically, if they can generate summaries from multilingual source, etc., etc. So to conclude, I think that it's extremely, we are going through very interesting times in NLP as in many other AI disciplines, because we have now an artifact, a model that serves practical purposes, notably for the big players of the internet that need to accommodate a lot of languages. So with one language, with one model, they can serve many languages. So this is extremely useful and extremely promising. But at the same time, these models, they display some kind of emerging behavior that is yet to be understood. There seems to be something behind this model that is related to the universals of language. So I think there are also extremely interesting science to be made studying these languages. But of course, to do this, we need more development, we need more models, we need models with more sources of data and more diverse language. And I think there is also a political aspect to this research, because as you saw, most of what is done for English. I think we have in Europe a large variety of languages. We have also this multilingualism problem to address, and we should look into building this kind of multilingual models for the European languages. And I stop there. Thank you.
So I think we still have time for one question. Yes, Josef, please.
So, very nice talk. I have one question related to, in these multiple languages, do you think, and this is for my background is computer vision, do you think adding images to the mix could help because they are kind of universal, they could act maybe some kind of a universal language with, for the translation, or would it be more a nuisance at this point?
Interesting questions. I mean, I have no idea. I mean, as you know more than I do, probably there are very interesting attempts to do multimodal language models, mixing images and also textual content. How would that help align somehow? I don't know. I mean, it's already remarkable the way they align, given sufficient data. But I'm not sure you would need images in the. But I mean, they could be seen also, as I said, as a kind of bridge between languages. I mean, we use we can use bilingual dictionaries. So I mean, a bilingual dictionary plus an image maybe can also. So it's clear that the more bridge resource you add to the system, the more reliable the alignments would be. So at the same time, I mean, it's something that needs to be tried. As I said, we need to do more research on this. I have no clear answer.